I've got here the UNI clamp meter. A clamp meter is a very useful thing to have. Normally, if you want to measure current, you need to have something that goes in line with the load. Something like this. This is the Turnigy 7-in-1 megameter. You plug your battery in one end, you plug your copter or plane in the other end, or whatever else is drawing your load, and the current flows through it, and it measures what your current draw is. That can be annoying if you're in a situation where you can't easily get something like that in line, like something is soldered up and so you can't easily disconnect it. Or also there's some risk involved. If you're working with especially high currents, there can be some safety or damage to your equipment concerns with disconnecting it. You maybe will need to use like an alligator clip or something to get it plugged in, and there's some risk. So what a clamp meter does is a clamp meter uses non-contact effects. For AC current, it measures the induced magnetic field around the wire, and for DC currents, it uses what's called Hall effect to measure the current without having to place the sensor in line. It just clamps around the wire and measures the current. So it's a very useful tool to have. It makes measuring current very easy. I've never heard of this brand before, and you probably haven't either, but it has very good ratings on Amazon, and so I thought I would show it to you. We'll go ahead and take it out of the box here, and you can see the box. This should be, well, it's all Chinese to me, but it's supposed to be an AC and a DC current measuring device. So measuring AC current with a clamp meter is very easy. When AC current flows in a wire, it sets up a magnetic field, and it's very easy to measure that magnetic field. This is the basic principle that transformers or radio antennas work on. So basically, with an AC meter, you're just going to have an antenna in the meter that measures the strength of the magnetic field, and that tells you basically how much current is flowing. With a DC, it's a little harder. So you'll often find the cheaper meters are AC only, and if you want to do anything with a RC plane or anything like that, you're obviously going to want DC measurements. So it comes with some probes. Fine, they look like decent probes. They have insulated tips all the way up to the tip. That's kind of nice. There's less chance when you're doing a measurement that you're actually going to cross the tips and maybe potentially short something out. Some instructions, fine, don't need those. And here is the meter, and a little case as well. And the meter is, one of the things this meter is supposed to have going for it is it's very compact and easy to toss in a bag or anything like that and take with you. And so here's the clamp that you're going to clamp around the wire. It also has this feature that I've seen this advertised for higher end meters like Fluke, where the jaws have a little bit of an alignment mark here. It's very important that the jaws have just the right amount of air gap, and that they be aligned properly to get accurate measurements. And so who knows how well that feature actually works, but it is a feature that's advertised on the more expensive meters. We've got this here for setting what we're going to measure. There at the bottom, that's where your actual probes will plug in if you're going to be doing any normal voltage measuring or resistance. And this one also, I don't know if you can see, it has a capacitance meter as well, so it can measure the capacitance. I don't know what the sensitivity of it is or how precise it is, but it is a nice thing to have. So I'm going to open it up, and apparently it does not come with batteries. It's no problem. I've got some batteries here I'll put in. I don't normally run rechargeables in my meters, but for now, for the tests, I'll just go ahead and do that. And here we go. We are in, let's just give it a test here. I have no reason to think that it won't be reasonably accurate. And it looks like it is trying to measure currents. Oh, by the way, this is also a true RMS meter. If you have an AC clamp meter, normally what it'll do is it'll measure the strength of the signal, and it'll assume that the signal is a sine wave. With an AC current, the actual amount of power is not related to the peak-to-peak. It's related to the peak-to-peak voltage, but the actual power is the root mean squared, and if you know the peak to peak, you can just multiply by a fixed ratio to get the root mean squared power. But if your signal is not a proper sine wave, then the RMS calculation is not going to be accurate, and you have to measure a little bit more carefully to get the actual amount of power. So a true RMS meter will not assume that the signal is a sine wave. A non-true RMS meter will assume the signal is a sine wave and just measure the peak-to-peak power and multiply by the ratio. The reason that's important is that some types of load, switching power adapters, for example, can cause the signal to not be a sine wave, the AC power waveform, and as a result, a non-true RMS meter will not be accurate in those situations. So this one is a true RMS meter, and it looks like, yeah, okay, so it looks like this switches between the clamp and whatever this is set to. So this is controlling the probes only, and this switch will switch us between them. We'll go ahead and we'll check the accuracy here against my other meter, although really I have no reason to suspect that it won't be accurate. The leads come with these little plugs in the end. That's a very nice touch. A little bit of a nice touch. Keep them from getting squished or deformed in shipping, I guess. We'll go ahead and we'll plug those in. And we'll put that into DC volts mode. And we'll find a handy dandy voltage source. There we go. 11.42. .43. Well, who's to say? That's as close as makes no difference. I will point out, I've just discovered this, that these shielded probes, as nice as they might be from a health and safety perspective, it does make it a little tricky to get in here. For example, I stick it in, and then I kind of have to cock it to the side and hold it, whereas these probes, it's relatively easy to just stick it in there. Now, of course, there's a risk that as I'm doing that, if I accidentally touch those probes to each other, that I'll short the battery, and of course that's not good. So there's a trade-off there between safety and convenience. So yeah, as to be expected, it measures out pretty accurately. But the real killer feature here that we care about is the clamp, and so let's check that out. Alrighty, so let's try it with this meter, my big quote-unquote industrial yellow meter, which I suspect is the most accurate one I have. The 10 amp fuse is actually blown on it, so this is gonna I think this is gonna pull just slightly more than 2 amps. So I'm using my other meter. Let's fire this up and see what we get. Yeah, so 2.4 amps. Now it's not reading anything. What's changed? Oh, I have, oops, hang on. I've got it clamped on the wrong cable, of course. That's completely accurate. Let's try this here. Okay. Check the 0 is correct, and let's try that one more time. Yeah, okay, there we go. So this one's wired directly in line, reading 2.41 meters. Oh, I have it hooked up backwards. It's reading negative, whatever. This one, 2.42. So really dead on. Excellent. Glad to hear it. And we can only assume that the AC reading would also be accurate. AC clamp readings are much easier to do than DC. So this is I think this is a great little tool. I'm really happy to finally own one. The ability to do a clamp reading is so useful for taking quick current readings in stuff that's already assembled. You don't have to unhook any wires from any terminals in order to get your current reading like you normally would. And especially if you're working with something like higher voltage stuff like 120 or 240, that's a real safety issue. Having to get your little meter in there and rig something up with alligator clips or whatever. Whereas this way, you just clamp onto the wire and boom, you're good. You get your reading. So the fact that it's small, the fact that it has the capacitance reading built in as well, this is all bonus. It also has non-contact voltage. So if you're trying to figure out whether a circuit is live, you just put the wand near the circuit and it'll tell you whether it thinks it's live. Again, this is not perfect. It's just measuring the magnetic field, so it can have false positives or even false negatives, but it is a nice thing to have. The only thing it doesn't have that I wish it had is the ability to measure inrush current. If you have a motor or a compressor, like on an air conditioner or a refrigerator, for example, or even just a big electric motor, you can get a huge inrush of current, maybe 3 times the running current, just for a very short period of time. And that can be too much to, for example, if you're trying to run off a generator, it can be too much and it can overload the generator. You might have a generator that's rated for 2,000 watts, and you've got something that's pulling 6,000 watts for a tenth of a second before it goes down to a manageable level, and it'll pop your generator's breaker. So the ability to measure inrush current is useful, and it's something I wish this tool had. It would make it perfect, but frankly, for $40, I mean, you're going to pay $150 to $300 for a fluke meter that has all those features, and this for $40, I really think it's an incredible bargain. At least, I mean, I've just unboxed it. If it falls apart next week, I'll complain and I'll curse. But for now, really seems like a great deal. I've got here the UNI clamp meter. A clamp meter is a very useful thing to have. Normally, if you want to measure current, you need to have something that goes in line with the load. Something like this. This is the Turnigy 7-in-1 megameter. You plug your battery in one end, you plug your copter or plane in the other end, or whatever else is drawing your load, and the current flows through it, and it measures what your current draw is. That can be annoying if you're in a situation where you can't easily get something like that in line, like something is soldered up and so you can't easily disconnect it. Or also there's some risk involved. If you're working with especially high currents, there can be some safety or damage to your equipment concerns with disconnecting it. You maybe will need to use like an alligator clip or something to get it plugged in, and there's some risk. So what a clamp meter does is a clamp meter uses non-contact effects. For AC current, it measures the induced magnetic field